This is 9.6, part 2. So, let's now find the exact value of each of these expressions. This is starting to be better in a way because we're not finding all 6 trigonometric function values. We just have this one for part A to do. So, as I said earlier, in the earlier part, pretend like that was a vertical line for the y-axis. Oops. Not very well drawn, sorry. So the initial side is on the positive x-axis. Go negative 240 degrees. So we haven't done negative angles in a while. Remember, that means to go clockwise. So from the positive x-axis going clockwise, that's negative 90, negative 180, and if I went to the positive y-axis, that would be negative 270, which is too far. So from negative 180 to negative 240, how far is that? Well, that's another 60 degrees. And so that is my terminal side of the angle. That's negative 240 degrees. Then I'm going to identify the reference angle size, which, if you were paying attention, is 60 degrees in size. That's how far it is from the x-axis to our terminal side. Then take any point on that ray for the terminal side, draw a perpendicular to the x-axis from that point to the x-axis, and then realizing that the marked green angle is 60 degrees, the side across from it, since that's a longer leg, is square root of 3. The short leg is 1, which is down here, and of course the hypotenuse is 2, because it's in the ratio 1, 2, square root of 3. The 1 is to the left of the y-axis, and it's a horizontal measurement, so that's a value of x, and because we're to the left of the y-axis, we'll assign that the value of negative 1 for x. Y is positive 3, square root of 3, because it's above the x-axis, it's positive, and r is always positive in the pre-calculus world. So, since cosine is x over r, that'll be negative 1 over 2, and we're done. B, tangent of 675 degrees. All right. So since that's bigger than 360, I'm going to find a coterminal angle for that. If I subtract 360 from 675, I'll get 315, and the tangent of coterminal angles is the same value, so I can clearly say this. And let me see, 315 degrees. That is the smallest positive coterminal angle I can get, because it is between 0 and 360 degrees. So I think I'm ready to get started with this. Drawing the angle, that's the initial side. We're going 315 degrees, 90, 180, 270. We're almost going to 360, but we're stopping before that. How much before that are we stopping? 45 degrees. So I'm going to go here 45 degrees away from completing the full circle. And there's my terminal side. So that's my angle that's coterminal. 315 degree is coterminal with 675. And the question I have is, well, what is the reference angle? And we did say it. It's how much further do we have to go to get from 315 to 360, and that was 45 degrees. So that's a 45 degree angle. Pick any point on the terminal side of the angle, draw a perpendicular to the x-axis from that point. Since this is a 45, 45, 90 right triangle, that means that the side lengths are leg is 1, and hypotenuse is square root of 2. So r is square root of 2. X is positive 1 because we're going to the right of the y-axis. And what is y? It's length 1, but where is it? It's below the x-axis, so that means y is assigned a negative 1 value. Okay, so the tangent of that angle will be y over x, negative 1 over 1, which of course simplifies to be negative 1. All right, so more examples. This one, the next one says to use a reference angle to find sine of theta and cosine of theta for the given theta. So we're finding both sine of theta and cosine of theta for each of these. Not all 6, so that's a little bit of a savings. So, first one, theta is 150 degrees. So let's draw that. Do you see how much I rely on pictures to sort of get my thinking straight? I'm kind of hoping you're picking up on that and thinking of emulating it, because I really do think that works well. So going 150 degrees, I've gone 90 to here. If I go to 180, I've gone too far. Well, how much too far would I be going? In other words, how much do I need to back up from 180 to get to 150? The answer is 30 degrees. So I'm going to draw this so that my reference angle here is 30 degrees. Then draw my reference triangle. Since that's 30 degrees, across from it, since it's the short side, is 1. The other leg, the hypotenuse is 2. The other leg is square root of 3. R is always positive. Y, 1 is above the x-axis, so y is positive 1. The x is to the left of the y-axis, so that means that we're going to assign a negative value to that x. Okay, so the sine of 150 degrees is y1 over r2. The cosine of 150 degrees is x negative square root of 3 over r2. Okay, we're done with that one. B, theta is 225 degrees. So we've seen several of these. What I would like for you to do right now is to pause the recording and see if you can find these answers on your own, and then come back and check with me and see how you did. All right, so the first thing I would do is draw the picture of the angle that's of interest here. Initial side, 225. Let's see, this is 90, 180. How much after 180 will I have to go to get to 225? Well, I need to add 45 to it, right? So that means I'm going this way, and the reference angle is 45 degrees. So drawing the reference triangle, picking a point on the terminal side of that angle, drawing a perpendicular to the x-axis. That's a 45, 45, 90 right triangle. So the legs are each 1 in length. The hypotenuse is square root of 2. I'll start with that. Since it's always positive, the hypotenuse is the value of r, so r is square root of 2. Since our x value is to the left of the y-axis, we're going to assign x to be negative 1. And because of the location of the point, y is below the x-axis, so y is negative 1. Okay, so the sine of 225 degrees, y over r, is negative 1 over square root of 2, which rationalizes to be negative square root of 2 over 2. And the cosine of 225 degrees is x over r, so negative 1 over square root of 2 again, And so that's also negative square root of 2 over 2. All right. So that's looking pretty good. Now, these are a few angles for which we can find exact values. When I say exact, it's like if there's a radical in that answer, I'm not putting that in a calculator and estimating the decimal approximation of it. So negative square root of 2 over 2 is an exact answer. And we can find exact answers for any triangle, at least right now. The only ones we can do is if there is a reference triangle that can be drawn, such that the reference angle is 30 degrees, 45 degrees, or 60 degrees, or if it is a quadrantal angle, which we covered in an earlier section, we could find all of those as well. Remember, those came in pairs. 2 were 0, 2 were 1 or negative 1 each, and then the other 2 were undefined. But that's all we can find exact values for. That's not all the angles that exist, however. So there are times when you're asked something like, to approximate, and that's a key word. That usually means pick up your calculator when they say approximate, or at least at some point in the problem, approximate it. That's not one of those angles that will give us a reference angle that's 30, 45, or 60 degrees. So this means pick up your calculator. Make sure that you are in degree mode, because that's 49 degrees, 12 minutes. And what I would do to type this is I would type cosine. There'll be a left parenthesis that comes up, I hope. It's in degree mode, so it needs to be in degrees. 49 is in degrees, but the 12 minutes are not. So I'm going to convert that to degrees by dividing the number of minutes by 60. Okay, so to remind you, if I have 12 minutes, to convert that to degrees, this has to be degrees, that has to be minutes, and that has to be degrees up there. How many degrees are equal to how many minutes? And that's why it's 12 divided by 60. Okay, so type that in your calculator, and think about how many decimal places I said I wanted you to round to. You should get 0.653 as your answer. Okay. Part B, cosecant of 197.977 degrees. Well, look as hard as you can. There is no cosecant button on your scientific calculator. So you're going to have to rely on the reciprocal identity to do this. And cosecant its reciprocal is sine. So cosecant is 1 over sine of that same angle. It's one of your identities that you're supposed to know by now. And by the way, for any of these, like cosecant, secant, or cotangent, for any of those three, I'm going to expect to see in your work that you write down this reciprocal. Okay, I need to see it. I'm going to grade that you write down 1 over sine of the same angle here. So that's required work. And then you type that in your calculator, and you should get negative 3.240. Okay, so I'd like for you to try C by yourself and then D by yourself, and come back and see how you did. So pause the recording and do C and D. All right, let's see how you did. C is cotangent of 51.4283 degrees. Cotangent is not a button on the calculator, so to calculate it, I'm going to need the reciprocal identity. Cotangent is 1 over tangent of the same angle. So that gives you an idea of what needs to be typed in the calculator. And you wrote this line because I'm going to grade this line, this statement, the fraction I just wrote. And after typing that in your calculator, you should get 0.797. Notice I'm rounding to 3 decimal places, which is my default number of decimal places, unless the directions say otherwise. That's what I'm expecting to see. Okay, and then how'd you do with D? Let's look at it. D is sine of 30. Well, it's easier than that. There's even a button for sine of 30, okay? When you type that in your calculator, you got negative 0.988, right? Right? Did you get 0.5? Well, if you did, I caught you. Sorry about that. This is sine of 30, not sine of 30 degrees. If the number does not have a degree symbol on it, it is in radians. And so for part D, you had to change your calculator into radian mode. So do that. Then retype sine of 30 and make sure you get this answer. Okay. Now, there are times that we want to reverse this process. Instead of finding the sine of a number and getting an answer, we're going to start with that answer and see if we can figure out what angle was involved. For example, if I had this equation, sine of some unknown angle theta is approximately 0.9677091705. What you're going to be using to find this is something called inverse sine. To solve for theta, and I would want you to write this down, theta will be found by doing sine inverse of that number. Now it's going to give you an angle answer, and depending on what mode your calculator is in, that's the kind of answer it's going to give you. So notice the directions for this one say find an angle theta in degrees. So if you're not told that, you're going to have to guess. And that doesn't make you feel comfortable any more than it does me. So if it fails to say what mode you should be in, degree mode or radian mode, if they don't say, I would like for you to start assuming that I'm always wanting radians. If the directions don't say, assume the answer is in radians. This one actually has directions that say use degrees, so make sure you're in degree mode, and you should see 75.4 degrees approximately. Okay. Okay. B. Oh, and what I'd like for you to assume for this one, for these problems starting here, is that we're using 3 significant digits. Okay, so that's why I did 75.4 degrees, because sometimes that's the, instead of 3 decimal places, not 3 decimal point, then number, but 3 significant digits. So 7, 5, and 4 are significant. That's 3, and that's what we rounded to. I know I forgot to say that up front, so I apologize. Okay, the next one says use a calculator to find an angle theta in radians that satisfies the equation tangent of theta is about 0.25. So make sure you put your calculator in radians, in radian mode. Again, we'll have to use the inverse. So this will be inverse tangent. Did you find that on your calculator, by the way? Usually it's you hit a second or alt or some other thing that allows you to access the things written above the button. And so like second sine on most calculators gives you sine inverse, and second tangent gives you tangent inverse. At any rate, tangent inverse of the answer 0.25 will give us the angle that we're looking for, and you should get 0.797. 2, 4, 5. That's 3 significant digits. Okay. There we go. We'll come back and talk about inverse trig functions more. Right now, what you're worried about is finding the angle theta if the sine or cosine or tangent of theta is equal to a given value. You're going to use the inverse sign to get that answer. And like I said, we're going to come back to that a little bit later and go into it in a lot more depth. We'll still see some of those now, but I do want to tell you that we're going to come back to that idea later. All right, so the next set of examples says find the acute angle theta, so we're doing the same idea again, that satisfies the given equation. Express your answer as an inverse trigonometric function and as the measure of an angle theta in degrees. All right, so A, cosine of theta is equal to 1/2. Okay, before I get started on this one, I want you to think back to what we did earlier. You may want to look this up. When we first did 30, 45, and 60 degree angles and did all 6 trig functions, I want you to look at all those answers, and that's a pretty small set of numbers that I would hope that you'd recognize. If the cosine or sine or cosecant or whatever of theta is equal to one of our frequently seen in that list values, like 1/2 is in that set of values, then I would expect that you can find this one without the use of a calculator. So when I see cosine of theta equals 1/2, no calculator. If I see tangent of theta is square root of 3, no calculator. So kind of familiarize yourself with those values so that you can tell when I would expect you to do this without a calculator. You might find it helpful to draw a right triangle, maybe not to scale, and I'm guessing that it's probably not right now. And to me, I think what I meant was that the bottom base, bottom leg, the base of this triangle is the shortest side. And since cosine of theta is adjacent over hypotenuse, I drew it so that this would be a 1 and the hypotenuse is a 2, and which means this is square root of 3. So really the answer I'm looking for is for this angle to be the one we're worried about, because the cosine of that angle is adjacent 1 over hypotenuse 2. So it's this angle down here, not the one up at the top of the triangle that we're worried about. And this is a triangle that we're familiar with. And what is the angle measure that's across from the square root of 3? And that's what you're going to have to be thinking about. Okay, well, first they did give us directions to write this first of all as an inverse trig expression. So theta will be cosine inverse of 1/2, and if this were a calculator problem, you would realize that you had to be in degree mode because of the directions, and you could type this in. Please don't first. I mean, you can do it in a minute to check, but this is something that you need to be able to do without a calculator. Using the picture to the left, I know that theta is 60 degrees. Okay, B. Tangent of theta is 1. That is one of our special answers, and it comes from, because all of these are fractions, 1 over 1. And tangent of theta is y over x. So that means both x and y are 1. So draw a triangle, a right triangle. Since this is familiar, you should know that I'm letting x equal 1, and I'm letting y equal 1. And this is the 1, 1 square root of 2 right triangle. And the theta, which is exactly tangent inverse of 1, is what angle? Right, this is an isosceles right triangle. So this is a 45, 45, 90 right triangle. So this is a 45-degree angle. Notice I'm writing a straight equal sign because those are exact answers. Whereas above in part B that you can still see where I wrote theta is approximately 0.245, we write approximately because we rounded some longer mini decimal, probably infinitely many decimals without repeating. Most of these are irrational numbers for these non-special ones. And in fact, a lot of the special ones are like square root of 3 over 2 is exact, but as a decimal, it's irrational, so it would go on forever. And if you were rounding it to a decimal, you would have to put approximately equal to. But if you're writing square root of 3 over 2, that would be equals. Just saying, just so that you're aware of what's going on. Okay, so there was a problem we did a couple of times ago where we were talking about the grade resistance. And I gave you this formula and told you do not memorize it. Of course, if they talk about grade resistance, you're going to have to look it up probably. We're supposed to find theta in this problem, for which a 3,000 pound car, which they just told me the weight of the car is 3,000 pounds. Find the angle theta for which a 3,000 pound car has a grade resistance of 500 pounds. So they're telling me that the grade resistance F is 500 pounds. Okay, well, since we have the formula and we've identified the values with the correct variables, substitution will say that we get 500 equals 3,000 times the sine of theta. I'll tell you that in solving trig equations, and this is one of the first ones we're seeing, the first thing you want to do is get the sine of theta by itself. And of course, that involves dividing both sides by 3,000. And that simplifies to be 1/6. Okay? So, using what we've been talking about, 1/6 is not one of our special answers. So, I'm going to have to pick up my calculator, and theta will be found using sine inverse of 1/6. Now, in this particular one, I want you to use degrees. I know the directions didn't say, but these angles in these highway problems are usually in degrees. If you think, talk to a surveyor who does this kind of measurement, they use degrees a lot. So because of the context of the problem, we're going to go with degrees. So make sure you're in degree mode, and you should get 9.594 degrees. Okay, so that wasn't that hard. All right, now moving on to the next level of difficulty. This says to find all theta values on the interval that's given. So all theta values in the interval from 0 degrees to 360 degrees, including 0 but not including 360, such that cosine of theta is negative square root of 2 over 2. Now my hope is that you've been working with this long enough that you realize that that rationalized answer came from something else. And I'm hoping you remember that that came from 1 over square root of 2. And of course it's negative. And cosine is defined as x over r. So if x over r is negative, which of those two is negative? Well, it has to be x because r is always positive, right? So because of this, we're going to claim that we think x should be negative 1 and y should be the square root of 2. So let's draw a picture of any possibility for which that would be true. Well, x being negative 1, let's say negative 1's right here. So that's -1 in length. And, oh, I wrote y. Man, oh man. Glad I looked back over there. That's not y that's square root of 2, it's r, right? Wow. I do not know where that came from. This is not a tangent problem or cotangent problem, either one. This should have been r. That's square root of 2, because r is the positive thing. So in thinking about that, I know that it's a 45, 45, 90 right triangle, because I have 1 something square root of 2, and it's 1, 1 square root of 2 is the special one that we've been thinking about. So what could y be? Well, I know that it's 1 in length, but what could its value be? Well, it could be a positive number, 1, right? And so this could be our triangle, where this is square root of 2. That's a possibility. And while we've got that one drawn, let's go ahead and figure it out. If this reference angle in here, for the 1, 1 square root of 2 situation, that angle should be a 45-degree angle. And notice I knew I wanted to say 45 degrees instead of pi over 4 radians, because they told me that my angle is in degrees right there. The other directions you might see is from 0 to 2 pi, including 0 but not 2 pi. That would indicate you're supposed to be using radians. So the reference angle there is 45 degrees. So this is 45 degrees in size. And what we're tasked with finding is the angle in standard position. So here's the initial side, and it goes to right there. Well, that 45 degrees means we're short of being a full 180, half the circle, by 45 degrees. And so one of our answers is 180 back up 45, and you get 135 degrees. Again, that's 180 minus 45 degrees. That's one of them. Okay, and I've drawn so much on that picture. I don't want to draw the other one in the same picture, although usually I would, but I've done a lot of labeling that I might not necessarily always do. So let me draw another picture over here for the other major answer. Hopefully you know what I'm talking about, that this is not like, oh my gosh, what's he saying? The other possibility, if this is -1, the first possibility was that y could be +1. The other major possibility is y could be negative, because the information we have doesn't give us any information about y. So we have to allow for every possibility. When x is -1 and r is square root of 2, we have to think of every possibility. And so that reference angle, again, when r is square root of 2, that reference angle is again 45 degrees. But that's not the question. The question is, what is the angle from the initial side to that terminal ray right there? Well, we're going 90, 180, and 45 more. So 180 plus 45 means that we are getting 225 degrees. So these are all of the angles between 0 and 360 degrees, including 0 degrees, for which cosine of theta is negative square root of 2 over 2. Two answers. Okay. All right. Now let's do one that's a little bit more challenging. A lot of times the problems throughout the examples get a little bit more difficult each time. Let's find two angles. Find two angles in the interval from 0 to 2 pi, which now means we're in radians. So pay attention to that. We're in radians. That satisfy this equation, cosine of theta is approximately 0.362 357, 7,545. Hope I copied that right. 36235, 77545. Yeah, okay. So, well, this one is not one of our special answers. I'll just tell you, that's not one of our nice ones. So this is definitely a calculator active problem. Well, if you pick up your calculator, you know that to find theta, you're going to have to use cosine inverse of that number. And how many answers will you get when you type this in your calculator? Well, since your calculator is a function machine, it only gives one output for each input. So you're not going to get two answers out of the calculator when you type this in. You'll get one of them. Okay? And when you type that in your calculator, you'll get, oh, I didn't record enough decimal places. So let me do this. Make sure I'm in radian mode. Check. Cosine inverse of 0.3623577,545. Oh my goodness, that's actually, I guess that's why I put that in there with all those digits, is that's actually equal to 1.2. Interesting. Okay, so that's 1.2. Well, this is where you're going to have to think a little bit harder because you're not used to it. If I were to draw a picture, and I'm going to do this time to help you as much as I can, keep in mind that this is 0, pi over 2, pi, 3 pi over 2, and 2 pi. 0 and 2 pi are coterminal. I'm going to write both of them there. So it might be helpful if you have in your head, or can type it quickly in your calculator if you need to, decimal approximations for these values. I bet you know the second one already. And you can approximate the others pretty quickly, to be quite honest. Since you know that pi is pretty close to 3.14, if you divide that by 2, you'll get pi over 2 is about 1.57. And if you multiply that by 3, you'll get that 3 pi over 2 is about 4.71. And 2 pi is double pi, so it's about 6.28. The one I can never remember is 3 pi over 2. The others I can kind of do in my head, starting with pi, but the 3 pi over 2, I sort of messed that one up. But nevertheless, those are kind of nice to know. So the answer 1.2 is less than pi over 2, right? So I'm probably not going to draw it in the right place. I'm just going to assume if pi over 2 is the positive y-axis, 1.2 is getting pretty close to that. So I'm going to say it's right there. That doesn't mean it is. It's just pretty darn close to that, okay? So this is a reference angle, which equals the angle itself of 1.2 in size. Now, if you'll look at the reference triangle that could be drawn for this, since it's cosine, we have to use the exact same x, whatever it is, and the exact same r, but the other answer can have an opposite y, right? Y can be positive or negative. So if this is y, then the other triangle that we're going to draw is going to have the exact same x, so it's going to be to the right of the y-axis, with a negative y that's the same length as y. And of course, if we draw this here, that's supposed to be the same as r. Now, it's not a perfect picture, obviously. I can't draw perfection. But that's what the other angle is. And its reference angle, of course, is also going to have to be 1.2. The reference angle doesn't change just because your answer's in a different quadrant. So the pink one is our first answer. That's done, okay? That 1.2 is a good answer. To get the other one, I want you to realize that we're going to start at the positive x-axis and go all the way around to there. That's in the fourth quadrant, so that's when I usually say, well, that's almost all the way around. It's not all the way around, and so how much do we need to back up from all the way around to get this angle? Well, all the way around would be 2 pi in radians. Please don't write 360. Then we'll subtract our reference angle from that to get the angle from the positive x-axis all the way around to that terminal side. And so our answers are, and I'm going to write it approximately because the second one is only approximately correct because of the 2 pi. 2 pi minus 1.2 is 5.083185307. And if we use 3 decimal places, that should be 5.083 is what we round to. And by the way, as a double check, 3 pi over 2, which is before that angle, is 4.7. And then after that comes 5.08. And then after that, when you get all the way around, that's 6.28. That 5.08 where we drew it makes sense. It's not drawn perfectly, of course, but it makes sense. Okay, so let's do another one. The two angles in the interval 0 to 2 pi, so we're in radians again, such that the sine of theta is approximately 0.3148. So if we pick up our calculator and type this in, oops, forgot the negative, you're going to get one answer because this is a function machine. So we'll have one to start with. And that ends up being negative 0.320 and more digits than that. But that's enough of it for right now. So let's see. Let's draw a picture of this. Negative 0.3. Well, negative means I'm going in a clockwise direction. 0.3 isn't very far because remember pi over 2 is 1.57. So this is about a fifth of that. So I'm not going to go very far. Let me say it's right there. Oops, I forgot to change colors. I always like to do this in a color-coded way so that it makes more sense. Now, I don't think this is a good drawing because that's obviously a little bit too big. I think that's more than a fifth of the way. But I think it's good enough for our purposes. So that is our reference angle, 0.320. And actually there are more digits to that. So don't clear your calculator because you want to use the number that's in your calculator and not retype this number. Okay, so anyway, what we're trying to find is another place where that could happen. Oh, you know what? That's not actually a good answer because it's negative. Because our answers have to be between 0 and 2 pi, implying they're positive or 0. So that answer is not actually okay. What I'm going to have to do is get a coterminal answer to that one. So to get the coterminal answer, which is all the way around here, I'll take that answer and add 2 pi to go all the way around the circle. right? Isn't that what we said before? So that means that our first answer is actually 5.96293937. And the reason I'm writing all those digits is to make sure you actually used the number in your calculator and added 2 pi to it, and you didn't type negative 0.320 plus 2 pi. I want you to check all these digits. Now we're going to round it, of course, as we have been doing. But again, I did that to make sure that you are doing what you're supposed to do to get the correct answer. Okay, that's only one of them. Yikes, you thought that was a lot of work. We're not even done yet. All right. So since sine of theta is y over r, and here we have a negative y, right? Y has to be negative because our sine answer is negative. And because r is always positive, that means y has to be negative. So where else could I draw a triangle, a reference triangle, where y is negative, r is positive, but and right here I already have a positive x. So what else could I draw? Well, if you're thinking about it correctly, you'll realize, I hope, that if you use the opposite x, you'll get the same negative y and the same r. So what we want is this angle. The reference angle here is still the 0.320. So now that that's gone from your calculator, retype sine inverse of negative 0.3148 so you get that back. And let's think about how you'll get that. See, what I was thinking to get this, if I didn't have that in my calculator right now, what I would be thinking to get there is starting at 0, I'm going to go to the other end of the x-axis, the negative x-axis, and that would be pi so far. And then I want to go the reference angle, I need to go that much further. That's what I really want to have happen. But the answer in our calculator is not negative, not positive, it's negative. So what could I do with pi and a negative number? What operation can I do between them that would have me actually adding? The answer is subtract the negative thing. So this is what I know I want to have happen looking at the picture. I want to go halfway around and then another 0.320, because that's the size of the reference angle. To make it happen with the number I'm given, I'm going to type pi minus that answer. Okay, so type that in your calculator, and you should see this number, 3.4618386. And again, if you don't know how to do that in your calculator, to take the answer from sine inverse of negative 0.3148 and do pi minus that answer, please ask me in class, because that's really important that you're able to do this. Okay, so rounding to the correct number of decimal places will get us 3.462. 3.462. And those are the two angles. And if you want to consider, does that make sense? Pi is 3.14. 3.462 is just a little bit further along. That makes sense to me. It's just past pi. 3.462 is just past pi. Say that 16 times fast. Woo, just past pi, just past pi. Okay, anyway, sorry. I humor myself sometimes. Okay, so the directions here are the same. Two angles. Find two angles in the interval from 0 to 2 pi. but this time we want the angle such that the tangent of that angle is about negative 4.631. All right, so I would like for you to pause and see if you can do this one by yourself. Okay, you're back, I hope. So, in radian mode, because it's 0 to 2 pi, to get the primary first answer that we can get on a calculator is going to be using tangent inverse. Okay, so you get an answer that is negative 1.3581256. That's what you see in your calculator. Maybe more, a few digits. I don't know how your calculator's set up. And this is kind of like the last one. The negative answer is not acceptable. So we're going to have to think about, when we draw this, the terminal side is negative 1.35. I know that half of pi is negative 1.57, so it's not that far, but it's kind of close to that. So I'm going to say it's right there. That is the negative angle. Okay, so the actual angle there is the negative 1.358 number, which means that the reference angle size is the acute angle between 0 and pi over 2. So positive 1.358 is the reference angle size. That's this angle size. All right, so because we are working with tangent, that's y over x. Y over x is what this negative 4.631 is equal to. Since that's a negative number, I should have written that up here. Since that's a negative number, it's possible that y is negative, which is what it is here. Y is a negative number, and x is positive. Okay, so that's one possibility. Y negative and x positive. Well, what's the other possibility? Well, the other way to get a negative answer, it would be for y to be positive and x to be negative. So we're going to draw that second one in a second. Before I do that, however, I want you to realize that that negative answer we got is not acceptable. We have to find the angle that starts at the positive x-axis and goes all the way around to there, which is what we did last time. So our answer that we're going to accept is a coterminal answer to the one that we were presented by our calculator. We're going to have to add 2 pi to get a coterminal answer for that that's between 0 and 2 pi. And so you should get 4.925 059692. And again, I'm giving you all these digits so that you can check that your calculator shows all of those digits correctly. If it doesn't, we need to talk in class about it, because you need to be able to get that number. Okay, and then rounding to the number of digits that I've said I'd like for you to default to, 3 numbers after the decimal point. That would be our first answer. Okay. Oh, and by the way, all along, I could have been saying this and I just forgot. You can actually check this answer, all of them, by taking your answer, and even if you don't have all the digits anymore. So let's actually go up here and check one of these. Let's say that we check this one right here. or we can check both of them, but let's just start with one of them and you can do the other one yourself. Well, the sign of that answer, according to this first line, if I type in 5.963, you realize that that's not all the digits of that number, right? So when you type that in, it's going to not give me exactly what I see up there, but it ought to be really close. And make sure you're in radian mode. So this should be, let me type this in my calculator and see what I get. Make sure I'm in radian mode. Yep. So if I type the truncated number that I just wrote down, the 3 decimals, and don't have all of them in my calculator anymore, I get negative 0.31474 stuff. That's not that number up there, but it's close enough for me to think, because 5.963 was rounded, and that's what I typed in, I should only be really close to the actual answer, not it perfectly. And I think 3147 and 3148 are pretty dang close. So you can actually check all of your answers in this kind of problem. Since you're going to have your calculator anyway, you should check this one and you should check the other one. And again, because I've gotten past the point, I don't have all of those digits stored in my calculator anymore, so I'll only be approximately correct. So let me type that one in as well. Sine of 3.462, and that's negative 0.31495 stuff. Is that close enough for you to think that it's a good answer? Yes, it is close enough for me to be convinced that that checks out. So this is the check, and I don't really need to see this check. This is for you. So that if it doesn't check out, go back and figure out what you did wrong. Maybe you subtracted 2 pi or did pi minus or pi plus that number and you got the wrong answer. This is a way to check yourself and make sure that you're okay, because this is a problem that you can check, and I would, especially when you're first doing it. You don't know how hard this might be for you to do, and there are plenty of places to mess up. So I would right now check. I'm not going to go through this one, but I would check the 4.925 number right now. Tangent of that answer should be very close to negative 4.631. If it isn't, tell me about it in class and tell me I messed up, because I'm going to have you do that. I don't want to do it right now. Okay, the other one. And in fact, I'm going to draw this in a different picture so that that messiness doesn't mean that I can't actually get anything. So what we've done so far, the one that we just did, was the one where we assumed y was negative and x was positive, because that's the one the calculator gave us, was the 4th quadrant answer, because we plotted that negative 1.358 number, and it led us to know that x was positive, y was negative. So what I'm going to draw next is a triangle. It has to have the same reference angle size as that one. It has to be a reference triangle. But this time I want x to be negative. So I'm going to go this way and have the opposite of x with a positive y. Oops, I drew that in the wrong place. A negative x with a positive y. That makes sense? And since this y down here I've written as a negative, this would be the opposite of that negative number, which is a positive number, because this y here is negative that I wrote. I guess I could have written negative y, but I didn't think about it until just now, so sorry about that. Okay, so this is the reference triangle we're talking about. There's the reference angle that's the same size as our reference angle. So the size of that is about 1.358. The angle we're getting starts here and goes to there. Well, to figure out what this one is, think about this. If I went all the way to the negative x-axis, that would be to pi. And how much do I need to back up? to get to our angle, we need to back up 1.358. So to do that, I'm thinking start at pi and back up 1.358. Okay, I'm not looking at right now at what theta is in my calculator. I'm looking at how to reason that it would be pi minus that answer. So now that I've got that, I'm going to think, oh wait, but if I retyped tangent inverse of negative 4.631, if I retype this to get this, the answer in my calculator is negative. So to get this other angle, it's already negative, so I'm going to leave it alone. And if I want pi minus that, isn't that the same thing as negative 1.358? Oops, well, what a mess. Plus pi, isn't that the same thing? So over here, I'm going to retype that, get the negative 1.3 number in again, and add pi to get our angle. And so what you should see in your calculator at this stage is 1.783467. Extra digits because I want you to make sure you're getting all of those digits right, and then rounding to 3 decimal places, so 1.783. And then, of course, you can check. Tangent of that answer should be very close to negative 4.631. And tangent of 4.925 should be very close to negative 4.631. And if it's not, then we need to go back and figure out what we did wrong. All right, so that's the end of this lesson. I will see you in class.